Welcome to Tidslinjen Podcast. Don't forget to subscribe.
Right. So the work I've done had a purpose, right? And so the purpose was to, I was sitting in meetings in Brussels, in European Commission meetings, and I was listening to plans for the future, what they call the green transition, their plans to phase out fossil fuels. And I'd just come in from Australia, from the mining industry in Australia, and there was a number of blind spots that were really apparent, and it was really quite prominent. And there was just a lack of numbers. So I was expecting to see the equivalent of a scoping study.
Okay.
As in what we call feasibility has a series of stages. It goes scoping, pre-feasibility, feasibility, and then you've got an engineering execution plan, which then goes into tender and off you go. Because we've been talking about phasing out fossil fuels for such a long time, and what we were talking about hadn't really changed much. Since the mid-2000s, it was going to be wind and solar.
Yeah.
Right. So, okay. So we know what we're doing. We don't need to work anything out. We just need to get on with it. And I was like, all right. And so, yes, there are innovations and everything, but there should be a plan on the ground. And there wasn't. I was expecting there was no scoping scale, which is like, back of the envelope, basic numbers level done of a plan. My work is the equivalent of a scoping study. It's a very, very basic look at a concept to see what it could be. And, this region consumes this amount of power. We're going to phase out these fossil fuel systems. We're going to put these new systems in. They're going to have this capacity. There'll be these numbers. There'll be this supporting infrastructure. There was no plan for fundamental industrial reform.
Okay.
And so there was lots of talk. There were lots of, yes, we're going to do this and we're going to do that. But there was no physical steps. We now need to develop 20 terawatts of electrical capacity for Northern Europe. There wasn't anything like that.
No.
So I put together this information to do it. And I tried to look at everyone, what other people have done, but I very quickly found that this was systems-based thinking, and everyone thus far had not really gone by this approach. And I found myself more or less alone. I asked, the basic question was this: what is the circular economy? How big is it? What raw materials should we be chasing in it? At the time I started this, the battery revolution was being talked about very much. And everything was battery.
Yeah, and what year was this?
This was 2018. And beforehand, I'd spent 3 years in Belgium learning industrial recycling and picking up on the circular economy. And so there was a lot of material there, that I could say, all right, well, let's do it. Is there any reason why we can't do it? No, there's not. Okay, let's do it then. So I did it from first principles. So instead of actually relying, there was an element, a generation of work where I was relying on academic peer-reviewed papers of, for example, how effective was an electric vehicle, how much energy would it require per distance, because peer-reviewed tends to take a couple of years, it's all old. And so when I sent it out for review, the first generation, I got thrashed. And so the commercial world has already surpassed this. There are commercially available electric vehicles that are much more energy efficient, and here are the metrics. And so bit by bit, every single theoretical part of the model that I had was taken out, and it didn't survive. And it was replaced with a commercially available off-the-shelf item, an electric vehicle, a hydrogen fuel cell, a wind turbine, and what have you. As for power generation, instead of actually from the corporate world in the mining industry in particular, when someone takes the stage and promises what they're going to do, we call it arm waving. And it's usually a company saying, give us money.
Yeah.
But what they say and what they do are often two very different things. And so I've seen the benefit of, instead of actually sort of taking someone's word for it, map what they do. So what I did was, for each energy system, I went to the Energy Observatory website, and I collected the data, the metrics data of about 10,000 power stations. It was about 10, 12,000, something like that, across all the different energy systems.
Okay.
What did they deliver across the year 2018? Not what they promised, but what they actually delivered. Because then we can actually capture things like, well, there were maintenance issues, there was bad weather issues,
Okay.
whatever.
And which different ones did you compare, like nuclear and wind?
So I went through the energy mix of what energy was used in 2018, like as in what was actually used, and then what is the energy mix proposed for the future, which, wind and solar take out 70%. And so all of those, we had oil, gas, and coal, but then we had nuclear, we had hydro, we had wind, we had solar, we had geothermal, and we had bio-waste to energy. And geothermal, I think I mentioned, yeah. What were the metrics? So you had a maximum and a minimum across the year, how much power was actually delivered to the grid versus what was the installed capacity of the units. So you had the maximum, the minimum, a standard deviation, and an average.
Okay.
So how many average stations would it take to deliver the power we need? Right. So, okay. And so then there was so how many cars are there in the global transport fleet? And this is interesting. No one had done that. Okay. As in, there were studies for the United States, and there were studies for Europe, and there were studies for China, but I couldn't find anyone to describe the global network. I think there was one guesstimate that was done in the year 2000 that I found that was out of date. I had to do it. So I found myself, trying to assemble it myself, and I assembled like news articles, and I went through it. And it's not perfect, but I came up with 1.4 billion cars travel, and then there's the estimate of what much distance did they travel.
Yeah, and it's cars. It's both fossil fuel cars and electric
all
cars.
All
all
cars, all transport. And so passenger cars,
trucks,
buses, trucks, vans. But then we also moved into trains, maritime shipping, aviation. All of it had to be modelled.
Yeah.
And every other study I came across, and this is why I left them all behind, really is they'd really only done like one tiny fraction of that. But like in 2018 in particular, everyone was interested in passenger cars only. They wouldn't talk about trucks at the time. They certainly wouldn't talk about trains or shipping. That's sort of changed now. And the assumption was, even though it's just 2018, it's 6 years ago now, and the assumption was the whole system was fossil fuel, and the whole system was now being transferred out of fossil fuel. At the time, the electric vehicle transportation fleet was less than 1%.
Okay.
Right. And now, since then, that transportation fleet has grown quite a bit. So, it tells a story.
Yeah.
So
would it even be possible? I mean, all that cars and transports and ships with today's technologies and today's scale. I mean, we're 10 billion people. Would it be possible to even replace those fossil fuel cars or transports with electrical? I mean, is it even practically possible?
It depends on the vector we use, like what direction we go in.
Okay.
If we are going to go in the direction of, for the last 150 years, we have built the system that's around us now with the most dense energy source the world has ever known. That's oil. But oil, gas, and coal are extraordinarily dense, concentrated pieces of systems of energy compared to the more dispersed systems like wind and solar. So we've built this system. There's been cheap, abundant energy. There's been cheap, abundant raw materials, and there's been easy to get credit compared to where we are now and where we're going. And now the system is so large, whereas if we were to start, say, a century ago, the system was much smaller. So the problem is the scale of the task in front of us is enormous, much larger than conventional thinking will allow. Is it possible? The problem is what we are trying to replace it with relatively exotic materials and using energy systems that are not as effective and as flexible as what we've got now. And so there's all sorts of bottlenecks and problems to overcome to move forward. I don't think the simple answer is no. if we were to do it the way we think we're going to do it. But human innovation is a thing. What might we do instead? But the purpose of this work was to show that the existing plan, as put out by senior strategic planners in the Western world, is not going to work. And if we go down this path, we're going to exhaust ourselves and waste time we don't have.
Okay. And what's that current plan, if we can summarize it somehow?
Okay, so it's colloquially called green transition, or sometimes the Green New Deal. It's all fossil fuel systems will be phased out. All transportation, which was petroleum-fueled internal combustion engine, is now electric vehicles or a hydrogen fuel cell. And now we've got things like ammonia fuel has now been considered. Or biofuels, that's the other one. The power generation, which is mostly coal, but then you've got gas and then a little bit of oil, is all phased out. And in its place, we've got renewable non-fossil fuel systems. And they are nuclear, hydro, wind and solar, geothermal, biomass to waste. Where wind and solar take out 70% or more, 76% actually, of the energy mix, as in they become the primary energy sources for the next industrial human civilization.
And they're all weather dependent, actually.
They're very weather dependent, highly intermittent, highly intermittent.
But isn't that already like a really stupid way to use as a base if it's weather dependent?
The problem is our society has become very ideological.
Yeah.
Right. So there was a fundamental turning point in the late 60s, early 70s, where society decided. It was actually marked by when we decoupled from the gold standard and with the US dollar, which then everyone else used, that money now become virtual, and money was the metric that ran everything. It was the centerpiece that ran all other systems. And that meant if we wanted to do something, we just printed more money, and we did. And so what set in was the idea that we didn't have to actually consider physical reality. And what we thought and what we felt was more important than physical reality. So here we are. Fossil fuels are considered bad. Okay. What's considered ethical is what's called renewables. And the reason we like renewables is the sun shines and it's infinite, and the wind blows and it's infinite. It will never stop. Right? But the people the world we're actually in the moment is also different, as 50, 60 years ago, every continent had the entire value chain for everything, more or less everything, from extraction of raw materials to all the way to manufacture, to growing of food, handling of waste. Everything was replicated everywhere else. And so everyone could see the whole value chain. Now we're in an era of globalism where things are very centralized. Now, here in Europe, we don't like to. Mining's considered unclean. Mining's considered unenvironmental. We don't mine. We will not accept mining. But what we do is buy things off the market. So it's like saying, where does milk come from? Oh, the supermarket. It's that kind of thing. Yeah. So what's happened is, the people who now lead us in these areas at a fundamental level, even though they intellectually understand that every physical thing has actually sort of come from a mining operation and a smelting operation and a manufacturing operation, they go, oh, that's someone else's problem.
Yeah.
Right. It's not part of the thinking.
Yeah. And so where is it being mined?
Say again?
Where is it being mined?
Right. Yes. Okay. So most mining for the metals control as actually the value chain is now largely controlled by one nation now. It's China. So what's happened is the last couple of decades, operations were sent to Southeast Asia, China in particular, because it was cheap to operate there. And there was a geostrategic plan that's been in place since the 70s by the Chinese to gather up all the industrial groups around the world and either control them on Chinese territory directly, or control them directly through the application of capital, where there's offtake agreements. And so they now control 60 to 70% of the entire value chain, from mining to refining to smelting, manufacturing components to manufacturing finished goods. Most manufacturing, for example, in Europe is made on components that are manufactured in China. And so what we do is we buy what we need off the market and it appears. Right. So where does a wind turbine come from? The market.
Yeah.
So it's a market action. And there's a general feeling that all actions are market actions. Just throw more money in it and it's fine. And then there's the perception that we're richer than anyone else in the world. Therefore, we will never be in a difficult position.
Yeah.
So there's also the general belief that resources are infinite. The planet is so huge, we will never, we are nowhere near tapping into those resources.
Yeah.
And right. So
yeah.
Sorry, go on.
Yeah. No, I'm just doing a simple analysis in my head, and it sounds like we're being dependent of China. We're creating a scenario where we need to be dependent of China for our energy production.
On the surface, that is true. What below that surface is we have allowed ourselves to be put into a very vulnerable position, and the outcome that the Chinese say, "Yep, I'll take that deal if you offered it to us." We offered it to them, so we are the architects of our own problems.
Yeah,
and that's not something that I see very well understood either.
Okay. Yeah, it's strange because in Sweden, I'm based in Sweden, by the way, and we used to have a fossil-free energy production once upon a time. We had like 12 nuclear plants. Mm-hmm. We had hydro, and we were basically fossil-free. And then we closed. I think we closed 6 nuclear plants, and now we have a problem with production, especially here in southern Sweden. So now we are dependent again on wind. So it feels like, and now there's being talks to rebuild nuclear plants. So we had a good solution, and then we took it down, and now we're trying to invent the wheel again. So do you see that? Do you see the same patterns in the rest of the Europe? Or
yes. So Germany is an excellent case study.
Yeah.
So through an ideology. Well, the problem is ideology is fine. We all have ideology. We all have beliefs, right? What I'm advocating for and what my work shows is once we have an ideology, we make a plan from that ideology. We then test that plan, not test it, but plan it out, map it out. If we were to actually do this, what's involved? And then we will compare the outcome of our plan to reality. Can we do this, or is there a problem? Those last steps don't exist. Right, well, we have the belief that the market will sort everything out. We don't have to do anything. Everything's fine. We're rich. Everything's sorted. We have to just focus on our beliefs and ideology, and the rest will just keep up because the free market will make it so. So those free market actions are now pushing us into a place where you are now obsolete. You are not needed anymore. You're not the most viable markets of all, and you've just lined yourself up for economic poverty. Right. So in Germany, they had coal, they had gas, and they had nuclear, and they had a massive renewable sector. But the renewable sector is balanced with fossil fuels because it's and this is the other blind spot. Wind and solar are highly vulnerable to the weather, especially in Northern Europe. Like in winter, your solar panels get covered in snow, which means they don't work so well. In winter, for example, the sun doesn't shine as often as it does in summer. It's simply like that. With wind, you have lulls of a couple of days long when there's no wind at all and the turbines just don't turn.
Yeah.
And so, all right. But the problem is when you have, say, 5 or 6 of those lulls a week apart, and the grid can never recover. So that renewable sector was balanced and controlled by fossil fuels, like gas in particular. Gas can be turned on or off. And winter is when we need more energy for heating. Right. The ideology was renewables are the way of the future. Things are going really, really well. Gosh, we're in control. We know what we're doing. And again, this is the ideology of we will only look at part of the value chain and the rest is assumed to be okay. Whereas when you're actually looking at the affairs of a nation state, it would behove us all to think in terms of a system. All parts of the state need to be considered and how they relate to each other. And if we make a choice, what happens to other parts of the system that we are not directly controlling or seeing. And this is the German mistake. So I'm using Germany as an example, but I've actually got a plan for them, like a way out.
Yeah.
So the people in Germany who are listening to this might be a little offended by what I just said, but I would say there is a way out. So we'll get to that. So what they do is they shut down coal and they shut down gas, and they shut down coal and they turned off the nuclear systems, but they still had gas. And then due to geopolitical reasons, the gas was cut off. Why was the gas cut off? Because we applied sanctions to the people supplying us the gas.
Yeah,
don't bite the hand that feeds you. So
it's Russia in this case, basically.
In this case, Russia was supplying 70% of the gas needs for Europe.
Yeah,
and there's a wider geopolitical plan going on there. And I believe there's a strategy underlying all that, and it is all about resources. And there is a conflict there that its primary domain is actually economic, not military. So the Russians turned off the gas. Coal had already been shut down. They'd also shut down a lot of nuclear plants as well. And they were relying on the renewable sector balanced by gas. Now, gas goes offline as well. And so, how do we get here? And so, our ideology said renewables were the answer and they could take over and fix everything, when they didn't quite understand the true metrics involved. Like, how long does it take? How many solar panels do they need to put in place to replace a single coal-fired power station? And so then they would make basic mistakes like installed capacity versus what electrical power was delivered. So you might have an installed capacity of, say 200 megawatts of big system, solar panels everywhere, great. But if the weather is very vulnerable and you've only got solar ratings such that you're producing power 11% of the time, and that's actually the global average, 11.4% of the time solar panels are producing electricity.
For the whole year?
For the whole year. So when you average it all for a globe, what that means is most of the time your solar panels are idle, and wind turbines are the same. And
what number is it for wind turbines?
So in 2018, it was 24.9%.
Okay.
Now, so engineering advancements can probably push that up to 33% now. But still, most of the time, those wind turbines are idle. Okay, yeah. So if you've got, so a politician would say, we've got a 200 megawatt installed capacity, we're fine. Then someone will come back and say, well, actually, you only produced 20 megawatts last year. Oh, someone's incompetent, fire them.
Yeah.
They don't understand the metrics of what they're dealing with because it all happened in the background with systems they no longer see.
Yeah.
And so decisions are being made by people who don't understand the full implications of it. So we may criticize the Chinese a lot.
Yeah.
Right. But most of their leadership are engineers and scientists. As in when they make choices about their industrial sector, choices are being made by people who understand the technical issues involved.
Yeah, we used to have that too in Sweden.
And what happened? The answer's here. What happened?
What happened?
Well, think about it. So the people who became influential and more important, engineering became so commonplace, so easy, it just happened in the background, and society at large shifted focus to another set of issues. And along that with a series of issues that, well, we don't believe, what we believe is more important than reality.
Yeah, ideology.
Yeah. So we all have that. Like, for example, take me. I breathe oxygen. I have an ideology that there will always be oxygen for me to breathe. I don't even think about it.
Yeah.
It doesn't enter my thinking. And so that basic issue is that the basic concept is transferred to many other subjects. So structurally over time, we've moved from one place to another, where we've moved away from the practical realities, which are boring. Tell us about that pile of rocks.
Yeah.
To a world where we can start thinking about, well, can we develop a fairer society or a more ethical or moral society? And what's interesting is while we've been focusing on that, ethics and morality have degraded right across the Western world. Like we are now there's more problems and difficulties on the books now than there were like 20, 30 years ago.
Oh yeah.
So again, why is that?
Well, I blame. I mean, I don't blame China. I don't blame Russia that much. I mean, they have a part of it in it, of course. But I mostly blame our politicians. I mean, they're the one in. Yeah,
we allowed this.
We did it. We did it. Yeah.
So, and to be frank, what the Russians and the Chinese are doing to us, for centuries we've been doing to them. Like when I went to Hong Kong to present to a group, and I actually met it was run by it was a conference on venture capitalism. There was amazing money, and there were 1,800 people. There were over 40 billionaires in the room.
Wow.
There were multiple rooms, and it was run by the People's Republic of China government. And I just got the feeling that things were they were on top of things. They knew what was happening. But when I actually talked to them, I said, right, the next century is ours. We're the next empire. They saw the American empire as the current global empire that they're in the process of taking down. Right, and Europe is subservient to the American empire. That's how they saw it. Whether that's true or not, well, that's if.
Yeah.
But the way they saw it is the next century is ours, and this is an interesting point. They didn't think in terms of vengeance, and what they would quote, for example, the opium trade wars, that the British started up an opium war so they could take tea from China. And on their terms. And so what the British did to the Chinese in the late 1890s, early 1900s was terrible. Right, and they remember that.
Yeah.
But they actually then take that as a reason of saying, we must never let this happen again in a loss of face context. Loss of face. This must never allowed to be happened again. We were saying before, we did this. Right, it says, we are responsible for what happens to us. We allowed ourselves to become weakened to the point where an adversary could take us down. That's how they think. We allowed that to happen. Our Chinese culture is 5,000 years old, yet these barbarians were able to do that to us.
Yeah, that's how they think, of course.
Right.
Yeah.
So then they will say, right, not only must things be corrected, so China now must become so strong that never happens again, then they talk in terms of vengeance. And they've been preparing for war for some time. And that war is economic. It'll go kinetic at some point else, but it's mainly economic.
Yeah, I think it's social too, not only economic. Yeah.
Fifth generational, multi-dimensional conflict where the opponent doesn't even realize they're at war.
Yeah, I think so too. They use social channels, they use economic channels. That's the new way of warfare.
But that's also linked with industrial espionage, cyber attacks, sabotage, the whole kit and caboodle.
Yeah.
Anyway, so that's a long-winded answer to your question.
Yeah, but it's interesting. It's really interesting because I think, like we in Europe, at least, we have dug ourselves a big grave, and we're having challenges now to come out from that grave. But I know that you have a plan.
So I have a plan.
Yeah, could we look at your plan to take us through this?
So what I would suggest is, hang on, why don't I instead of actually talking about it, I can show you. So let me know when you're seeing this.
I see it now.
Okay, so you see the full screen?
Perfect.
Okay, all right.
Yeah.
So the basic question is this: how do we continue to resource this? This system that we're in. Look at all this energy that's being used, and it's being used in a way that's very wasteful. Oil is going. So there's the climate change issue, but there's also resource depletion. This is oil production. In November 2018, there was a peak, and then then we have since we've come down a bit and we've not come back to that peak. That's COVID, the dip.
Okay.
And so we've come up to a plateau and we haven't been able to get back to this peak. Meanwhile, 81% of existing oil reserves are being depleted between 5 and 15% in an annual context. So the longer that goes on, the harder it is for that peak is to beat. So we've got a possible date for peak oil. So what this is basically saying is fossil fuels are going, think of something else.
Okay, so we're running out of it.
Yeah, not running out. No. What that means is roughly the amount of oil brought to the market. Let me go back to that. The amount of oil brought to the market can only get to a certain point, and it peaks and then declines. We've got roughly half the oil we've ever discovered still in the ground.
Okay.
But what it does mean is we've got all the cheap, easy oil out. Now all the expensive stuff is now coming. So we've got a thing where oil was cheap and abundant, and it was easy to come by, and now it's going to get harder, and now there's going to be supply and demand gaps, so it becomes an economic problem. So we're certainly not running out of oil, and that's not going to happen anytime soon. But it does mean our system of growth, where we want to grow and profit, now has to evolve into something else. So this is the green transition. So what I've done here is worked out how much metal we need for all the electric vehicles, wind turbines, solar panels, batteries, and stationary power storage and all that. The big difference between the scenarios is how big should that stationary power storage be. Conventional thinking believes we only need 6 hours, 5 to 7 hours. That's interesting, is they still think that, but then when you ask them, the sun goes down every night and solar panels don't produce electricity at night. Okay, so 5 to 7 hours won't get us through a single night, let alone winter.
Precisely.
Yeah, anyway, I still get flamed by people for saying such things, but anyway, so the real answer is between 28 days and 12 weeks. So it's between the red and the blue. So the column here, the grey, the white, and the black, this is actually the metal that we have in the ground. So grey is reported mineral reserves, white is mineral resources that are estimated, and those numbers are dodgy. The black is what resources we know of under the sea that we are at this time. So what is actually showing here is a vast disparity between the amount of metal we need versus what we've got access to. Now, remember, it takes a long time to develop a mine. You're talking the mining cycle, something like 20, 25 years for everything together. And so what this is basically showing is this is the standstill. This is for the first generation of units as things were in 2018, and the system's grown larger since then. So it's basic. This work has been published in the GDK Bulletin. The full calculation. What this is saying is this is not going to work. Find a better plan. So mining production, existing mineral reserves, resources, and recycling all together will not be enough to manufacture the first generation of renewable technology. Now, what I don't mention in there is we don't have time either, because it takes time to do this stuff. And we think we're going to do it in the next 10, 20 years. Anyway, so what this basically means is there's a black swan at the heart of our energy transition plan to phase out fossil fuels, and we really need to go to the drawing board and do something else. So the next bit here is to demonstrate that I'm actually thinking positive for the future. If that won't work, what will we do? I'm not saying we should go back to fossil fuels. Absolutely not. So we want electricity generation, we want transport, we want manufacture. We want reliable and consistently stable power generation in all weathers in all geographical regions, preferably in concentrated form, preferably with a low materials footprint. That's where the green transition fell over. A long working life for each unit, and everything's got to be designed to be recycled when it comes offline. Because at the moment, when our wind turbines come offline, most of them are not designed to be recycled. Minimal waste plume with a very low environmental impact. That's our laundry list. So if the green transition won't work, what might we do instead? So this is what I call the purple transition. And so this is the idea. We've got a number of black swans coming in, but some of them can help us if we see them differently. At the heart of everything is a reimagined commodity sector. So we have been managing our resources and commodities as if they're infinite, and money is the only metric. So we've got to think in terms of resource stewardship. And so I've taken the circular economy and I've evolved it into what I call the resource balanced economy. And this is an evolution of some of Jacques Fresco's ideas. Right. The power source at the sort of it is liquid fuel fission, also called thorium-fueled molten salt modular reactors. That's a technology that's actually 50 years old and is actually on the ground now in Copenhagen. And there's a group called Copenhagen Atomics, which are actually doing quite well. I believe the Chinese are already doing it and commercially selling power, but Copenhagen Atomics will be able to get their units out to market in 2028 if they can actually sort of get the regulations done in time. Okay, electric vehicles powered by chemistries not lithium. So do something else. Is it sodium? Is it fluoride? Whatever. So this is a short-range transport. Combustion of iron powder as a thermal fuel. So most of our manufacture is dependent on coal for heat. We're talking heat here. And some of the heat applications, most of the time it's around 1400 degrees, but sometimes we need to get as high as 2400 degrees if in some applications. We're not going to do that in large volumes with our existing plans. Like, you're not going to do that with solar panels and wind turbines. So I propose using a metal fuel iron powder, which is the same iron powder that's used in the powder coating industry. And what's interesting is when you combust it, that pure iron powder becomes iron oxide, which is also called rust. Strip the oxygen out with various different methods, and you can recycle the fuel. I'm suggesting that the pyrolysis of human sewage to produce syngas. Now, pyrolysis is the action of heating something without oxygen, and then it chemically breaks down. So human sewage is actually an energy source. We treat it as a waste product that causes a lot of problems, and it's very expensive. But if we change that around to take it and transform it, by doing this, it produces about 35% by mass gas. And the rest of it is things like biochar and liquid fuels, which can be used to make fertilizer, but organic fertilizer. So the syngas could either be used to make hydrogen with the sulfur iodide cycle, as in to take it the further step to get by burning part of it, or we can use it to recycle oxidized iron fuel powder. So you've now got a link between a human society waste product and recycling a industrial fuel. And the last one was ammonia-fueled ICE technology. So all their long-range transport, things like maritime shipping, intercity freight trains, what have you. There are a whole series of technical problems with ammonia. I don't think it's appropriate to have it in high-dense populations like cities. So because ammonia is actually toxic to living things, and it's a gas at room temperature and pressure. So if something goes wrong, people will get hurt. Which is why short-range transport in a city falls back on electric vehicles. But because each electric chemistry that I've seen needs, needs copper, it needs graphite, probably needs nickel, probably needs cobalt. They're all limitations. And so society will now have to be restructured and simplified to reinvent the transport system. And so I proposed a system for that. Okay, so here's how it looks. So you've got a series of things together that interrelate and interlock. So thorium power is our electricity and not a conventional demand, but we're now going to charge the fleet of electric vehicles, which is all our short-range stuff, with sodium and fluoride battery chemistries. Combustion of iron powder, we don't need coal anymore. We now just do it. We can have our own manufacture. From that, we can actually sort of facilitate the production of hydrogen production in conjunction with thorium molten salt. And that'll fuel our heavy vehicles, trucks, buses, and all that, so on hydrogen fuel cells. So hydrogen production also will facilitate steel production in a hydrogen atmosphere. This is like the hybrid system that's been proposed in Sweden. So from some of that hydrogen, we're going to produce ammonia, and that will fuel our long-range transport between cities and between continents. The thorium molten salt powder, the thorium molten salt system can also facilitate with the pyrolysis of sewage the recycling of the iron powder. So we're using the same material again and again and again. And yes, and that's the Venus Project group I'm now working with to actually facilitate this program. Anyway,
can I ask some questions on the
Sure.
previous slide?
Yeah, sure. Let me just hang on. Let me just get it back for you.
Yeah.
This one. Hang on.
No, the one with the triangle. Yeah.
Yeah.
So the first question is all this scalable to today's society?
So that's an interesting question. Everything I've modeled at the moment is it's all based around the idea of a small city.
Okay.
But there's no reason why it can't be scaled if we can manufacture the stuff. And when we're talking scalable, how do we manufacture large amounts of these? So the thorium molten salt reactor that's been proposed by Copenhagen Atomics is small enough to fit in a shipping container and arrives on a truck. In their factory, which I visited, they are planning to produce one of those a day. One factory can produce a thorium reactor that's actually producing 100 megawatts of thermal heat or 40 megawatts of electricity a day. So if we scaled it up and we did it many times, many factories, then yes, we can get them out. Do we have time? Remains to be seen because we've got to get out of our own way. Combustion of iron powder, there's a group called Metalot in the Netherlands that are actually commercializing that. They've got a series of pilot scale units they're actually relatively simple to operate. We don't need that many such units to replace our manufacturing sector. So that's scalable. The ammonia-fueled ICE group, Maersk Shipping, has actually got a system that's actually they've been running test units. They've been running like ship engines like for 6 months continuously to test the maintenance of it. That should hit manufacture pretty quick. The maintenance cycle on it, though, will probably be more strenuous than what we have now for our petroleum systems because of the nature of ammonia. There's no reason why that can't be scaled up. Toyota has made they've developed a concept car. They haven't actually released it commercially yet, but a passenger car fueled on ammonia, which means the technology is pretty stable. The question is, should we use it, and if so, where? The big unknown here is the batteries, because at the moment we're so focused on lithium-ion batteries that it's very reluctant to get anyone to talk about sodium and fluoride battery chemistries. So fluoride is highly corrosive, but there is a friend of mine called Rika Witter is actually developed a patent to get around that corrosion problem. But sodium batteries, the chemistries have already been talked about, but they're conceptual. We haven't yet to get to the point where we're making lots of them. Okay. So that's the scale-up problem there, the batteries.
Okay. And another question I have too is all the resources needed to do these things, do they exist in like an amount that we need, or will we have the same problem as with the current transition plan?
Actually, do I have it? No, it's not in this slide set. So let's go back to this one here. So the resources to make these things are actually pretty simple. Okay, so what is in a thorium-fueled reactor is mainly steel and nickel. Now, there are some exotic materials in it, but there's less of them. There's a relatively small amount, and each unit has a long working life. So the primary things are steel, are iron and nickel. The electric vehicles, things like sodium, and we'll come back to the electric vehicles. That's the limiting step. Combustion of iron powder is mainly a steel furnace with brass and a little bit of aluminium. Pyrolysis of human sewage, that's a furnace, again steel. And ammonia fuel ICE technology has the same basic footprint for materials as our current petroleum technology, which is mainly steel, plastic, glass, aluminium. They're all things that actually don't have that much in the way of resource constraints. We have plenty of iron, we have plenty of aluminium.
Okay.
Now, the trouble starts when we go back to the electric vehicle batteries, because every system I've looked at does require copper, does require graphite, for example, for the anode. Most of the time requires nickel. Some of the time requires cobalt. All of those will have resource constraints. So the electric vehicle system going to sodium batteries, for example, does solve some of the problems, but not all of the problems. And that is the point that society will be required to contract in size to become simpler when with a smaller footprint. But everything else on the board there requires mainly iron. Mainly. And with support things like, or things like aluminium and nickel and stuff that we've got plenty of. And if we're not going to have vast amounts of electric vehicles, then a nuclear reactor with nickel alloys in it will last comparatively a long time compared to, say, a battery in an electric vehicle.
Yeah.
So the resource footprint of this plan is inherently different to the green transition, and it's inherently different to what we're using now.
Okay. And is all this like financially sustainable as well?
Okay, so I haven't looked at the finance side of things.
Yeah.
Because there's two problems. That we've got inflation signatures now in double digits in many countries, so we're not that far off hyperinflation. That means if you make any market predictions, they're not going to last very long.
No.
The second problem is the biggest issue to get all this on the ground is getting, for example, a government to grant a license to allow a thorium reactor to appear. That is the problem. That orders of magnitude more complex than actually building the reactor itself. We've got to get out of our own way. And so the question is not so much financial viability as in, will governments allow this stuff to happen? In terms of financial viability, Copenhagen Atomic have a business model that is strong, so strong that they don't sell you the reactor. Well, they don't want someone like me playing with it, I suppose, which is why they're doing it. But what they do is they rent you the reactor and they sell you the electricity. And the electricity they're planning to sell is 2 cents a kilowatt hour. And that is much, much cheaper than any other system on the board. So what they're proposing is not only sustainably very good, but it's much, much cheaper. And as for the rest, well, the ammonia-fueled internal combustion technology will be more expensive than petroleum technology, but when petroleum becomes unavailable, then ammonia will become the cheapest available way of doing things.
Interesting.
I haven't done a proper map. If you're asking, have I done a proper business case analysis? No, I have not.
Yeah, I mean, you have done a lot, so we can't expect you to do that as well now, at this point. But it sounds really interesting. Actually, I haven't seen this before, so it's really, if you compare it to the transition plan we have today, I mean, this is actually more, how do you say it in English? It's more practical, and it makes more sense, and it's
from a different direction.
Yeah, and it's at least it's a plan. Because the one we have now is like ideological. They push it forward. They say 2030, then they will probably say 2045 and 2050. So this feels better. But I had one last question, which is...
I've got another thing to actually show is when I say I'm reinventing transportation, what do I mean by that? And
but was it also environmental friendly, your purple transition?
Yes, because if you remember that map that I was looking at, there are no emissions off that at all. None.
Okay.
Nothing comes off the thorium reactor. Nothing comes off. The iron combustion has very little. It has no carbon reaction at all. It's got a very, very small amount of nitrous oxide. And then the only emissions that come off that whole system, like electric vehicles don't either, is the ammonia ICE. Is the exhaust on that has got to go through a catalytic converter, and whatever is not comes out of the exhaust that's not combustible because it's not tuned is ammonia. And they're the only things and we're talking trace elements compared to what I got at the moment. So it's actually so different. It is such a different paradigm that it's what? The waste plume that comes off our existing system, exhaust out of coal-fired power plants and the exhaust that comes out of like petroleum ICE cars, none of that exists on that map. And so the environmental plume is more associated with the manufacture of those things, not with the operation of it. Like, how do you make steel? Well, now we're back to the hybrid system with the hydrogen atmosphere. So there is a vector through this. So what I would like to show now is, so we've got to reinvent transport. Right. So how's this for a game of soldiers? Let me know when you can see it.
Yeah, I see it now.
Okay, so the work I was referencing before, where I looked at the whole system. When you actually look at, we're going to phase out fossil fuels, and we're going to do the same activities on the other side, but without fossil fuels. And what I found was this. So if everything is either an electric vehicle, a hydrogen fuel cell, or an ammonia fuel for a ship, look at trucks. So trucks, 2% of the transport fleet in terms of number of vehicles are taking 42.8% of the energy of the transport network. Now, the electric vehicle fleet is the other 97.95%, but they're taking only 25% of the energy. Trucks are taking a disproportionate amount of energy. So replacing trucks is the problem. So we can't just phase them out because society runs on trucks. There's a book by Alice Friedemann called When Trucks Stop, where she looks at this issue, and I haven't really seen anyone else do that. And the other one is Life After Fossil Fuels. But what do trucks do for us? So the question then becomes, can we do the same thing another way? This leads to a different city architecture. So this is Jacques Fresco's work from the Venus Project. He was doing this stuff back in the 50s. So in the mid-70s, he drew these pictures, and he proposed the idea of a monorail. Now, monorails are a thing now. We know what to do. This is how we move large groups of people in light rail, and we know how to do that. Here's the innovation. We want to move large amounts of cargo of what trucks normally do. So this is actually a group called Futran. They're based in Nigeria. And they've proposed this idea. At a mine site, they want to move ore, like heavy cartloads of ore, across an 80-kilometre track between a mine and a shipping port. And normally when you put trucks on the roads, you've got to build the road. When you build a railway track, for example, there's a lot of civil engineering to make sure that the track is level. And this thing sits on stilts. And those stilts can cross rivers, valleys, gullies, what have you. So they've got like a concept track going, and so the carts go along underneath. And so they've done a lot of work to show the viability of it and everything. So this is the costs. So it's an 80-kilometre track. It's 1.6 kilowatt hours a kilometre for a skip. So here's the thing. We can do this with a shipping container or even specialized hauling. So instead of having a truck deliver, say, a shipping container. Oh, yes, let me back up for a bit. When you look at truck routes, they're non-linear. That is, trucks don't go down all roads. There's a disproportionate number of trucks going down a few shipping routes between major terminals, like a port and, say, an industrial handling area. So what I'm proposing is this system, what I call the spine rail, and where if you were to put a track between two strategically significant points, you're taking off not all trucks, but some trucks, right, off the road. And so we now move things around in a shipping container. So this is the engineering that they've actually done. And so this is instead of like ships going into trucks going into shipping ports, they come straight off the ship and they're elevated out to a workstation that's far away from the port, and so you don't have big lines of trucks. Okay, this is what I'm proposing. So on the frame, on the top, we have 2 monorails that are shifting people. And on the bottom, we've got a 2-way system that can ship shipping containers. And so what this does is it will, if you do this for a strategically significant route, I don't know, between, say, Stockholm and in a major industrial center, like one route. And how many trucks go down that route? How many trucks are removed out of the system? The monorail can shift people. Like one monorail can carry the equivalent of, say, 100 cars. I think that's the ratio, something like that. So we've got a massive reduction in energy consumption. So this doesn't remove all trucks, it removes some trucks. Now then the innovation is, well, then you start moving things like industrial centers onto this train line. And so, hang on, I put together a plan with the Venus Project. And this is what we've sort of put together. And so, actually, yeah, So if we had, for example, if we would apply the resource-balanced economy, let's say we had a concept city, but around the city, we've got a constellation of industrial groups, and they're on this train line. So everything that we need to do can actually go on that train line. And so we need the flexibility of trucks and vehicles that can go anywhere and anything, but all the stuff that we need to do and move large, it should be designed to be so. And then we design it and build it, and we're away. Anyway, so
Interesting.
So
Cool.
So I've put together this idea of the purple transition, where you've got a number of things that what we are doing is, what do we have to do for society, and work our way backwards to get that point. So instead of actually just saying we will now replace energy with this energy source and life goes on, we don't have to think. The whole thing has to be rethought.
Yeah.
And
Okay,
it's smaller in footprint. And what we're trying, let's say we're talking to the nation of Germany now, and it says, right, how do you develop your own industrial sector again? You bring back your industry, and you've got your energy sector, and you can do your home heating and electricity and all that. You don't have to talk to the Russians. You do it all on your own. You control it domestically, all of it. How do we do that?
Yeah.
Yeah.
But all these solutions you have, do you get any feedback from politicians? What do they tell you?
So I do present to politicians. The first generation was, the green transition won't work. The very first transition, work was the examination of the fossil fuel industry. No one wanted to hear that. They really didn't want to know. What do fossil fuels do for us? Don't care. Shut up. The green transition stuff, people, they were quite shocked. They didn't quite know what to make of it. They would say, well, we haven't really thought of this. And then when I go back and present a couple of times, that they still aren't able to refute it because they've used their own numbers. And I've come at this from a direction that no one else has. So all the people they normally fall back on to talk to about, who rely mainly on market analysis, it's either market analysis or carbon emissions. They don't talk about the raw materials involved or the physical number of units. So the word is shock. They go, oh gosh, yeah. Right, so that was the first generation. They were all, without exception, asking me what they should do. And that was demoralizing for me at first. But after a while, it became clear that I was in a unique position where I could put together a plan because I had been through a tour of duty of an understanding of what is needed, but also what might we do. So I had the threat matrix and I had the solution matrix. And then I sort of joined the two. So when I present the purple transition, they think, this is great. But they all say, we can't engage with this. The system at the moment has become to such a strong momentum to it. Everything's been optimized to a very narrow efficiency peak, the way things are now. And if each of these politicians and corporate leaders, for that matter, if they made even a relatively small change compared to what is needed, the system around them would replace them. And so I'd lose my job if I did that.
Yeah.
Right. And it's especially things like legislation and regulations and stuff like that. So they looked at the purple transition and said, this is fantastic. Let me know how it goes. So they want it to be done somewhere else so they can point to it and say, look, someone else is doing this. Why can't we? In the mining industry, they really did like thinking conservatively. They would want to see a risk taken by their competitor and then shown to be economically competitive for 20 years. Then they'll consider it, and then they'll want to take it, and it's theirs, and no one else can have it. We call it the first to be fifth.
Yeah. But what do you think will happen? Will we still be on this path we're on today and just continue, or what?
So what will happen is actually fairly easy from the point of view of our leadership and the way we are. We're going to hit a series of problems. Now, whatever those problems are, it's the way we will respond is your classic run about, wave your arms, scream and shout, have a meeting, hope for the best. It's not my fault. We're going to go through that whole sequence. You can see it happening.
It's already happening.
Yeah, to the point.
Our Minister of Energy here in Sweden, she blames the Germans already.
So this is the problem when the system is so optimized to the point where we're not really looking at the real issues, and the system is so optimized strongly to keep going in a particular momentum where people are genuinely helpless. It's not that they're stupid or incompetent. It's the nature of the system that binds us all together makes life very difficult. And it's just why nothing really happens. Nothing really changes. What will happen is something will break, or a number of things will break. And things that we normally depend upon for, something that we normally depend upon and we just take for granted, all of a sudden will become unreliable. And we're going to have an emergency meeting. And then what do we do? What do we do? And then they'll try a whole lot of stuff. I can see, for example, our political leadership will face two leadership challenges. And it's after the second leadership challenge that these ideas might be considered. So the first leadership challenge is, person X, you're in charge at the moment. You don't know what you're doing. Obviously, you're incompetent. Person Y, that would be us, can step in. And because we're better than you, we will do it okay. And that won't work either, because the structural problems are what they are. And then person Y faces a leadership challenge. Like, gosh. And person Z comes along with the understanding that the conventional thinking will not work. And then, and only then, would they be prepared to listen to unorthodox ideas. It is the environment of when the orthodox fails, turn to the unorthodox or accept failure.
Yeah.
That's the environment we're in. Something has to break.
And how far from that do you think we are?
I think things have already broken. In fact, I've got a chart that can actually show that the system has been in the process of transforming. Here we go. Let me share again. This is a... See, it's not a case of this will happen sometime in the future. It's happening now. All right. Can you see the screen?
Yep.
So I'm making the case that the change actually started in 2005, like 19 years ago. So what you're seeing here is the metal market price for the commodities of basic metals, precious metals, oil, gas, and coal, and all the fertilizer minerals. These are the elements that the World Bank uses to track the health of a particular, the world economy. So what I've done is so you've got data back to 1960 in a monthly resolution. I've overlaid the curves by indexing the number 100 up against December 2001, which is in here, that little point here. What this does is it overlays the curves, and you can see periods of relative stability and instability. From this point backwards, for example, was when we were running on a gold standard. From 1971 onwards, you had a level of volatility, but it was within a bandwidth. In 1979, this is the oil embargo from Iran, which sent everything nuts.
Okay.
But in 2005, that happened.
Wow.
Right. So what? So the largest financial crisis that we've seen since the Great Depression was the 2008 GFC, global financial crisis. That's in there. So that wasn't enough to correct whatever's going on. So it's not volatility. I make the case it started in the oil industry. And I've got to update the chart now. It started 19 years ago. Things are now happening so fast that I've got to change the numbers of the years of the charts. All right, so what happened? So this is oil. We are a petroleum-driven society. GDP links to it very nicely. See that little kink there? This is oil production. That little kink there is the Iraq War. Did I put it in? No, I didn't. Okay. So that kink in there is the 2003 Iraq War, which took off 4.6 million barrels of oil a day. Give war a chance. The Saudis were told to bring more expansion on, but they got to a certain point where they couldn't do it. So this is Saudi oil production. This is oil rigs, like the number of oil rigs actually extracting oil. So they got to a certain point here, like in January 2005, and so they realized their production was declining. See that this is their oil production, the solid line, it was declining. So they tried to bring on more oil rigs, and they said this is the rise. And so 146% increase in rig count in exchange for a 4% contraction. So that means that the Saudis were not far off peaking. They have since peaked. So oil plateaued. And so this is supply and demand, and that's oil price. For a period of time, production plateaued. And within that, supply and demand actually separated. Right. And that created a price spike. This is the price spike. You remember in 2007 when the price of oil just got worse and worse and worse, and everyone said, this is going to end badly, hey?
Yeah.
Right, well, it did. That was the global financial crisis. That was the trigger for it. And we fixed it with the printing of money.
Yeah.
And then fracking was been around since the 50s, but they had an innovation of horizontal drilling, which means that the tight oil sector can now produce vast amounts of oil in America. So fracking and tight oil was the shortfall, and US was now the global swing producer, not the Saudis. Right, same data. We're going to look at 1970 now. So the pinpoint is January 1970 and 100, so it's in there. This is what happens when we went from a gold-backed currency to all over the world, currencies were backed by gold or silver bullion. And then we went to a fiat currency system, which is, there's no physical backing. It's just backed on confidence and what we can just make stuff up. And when the 1973 oil embargo first happened, which forced everyone to engage, where all oil trades were now done in US dollars. So it forced the world to engage in a fiat currency as the global currency. And they didn't understand at the time the significance of that. But that's actually when the trouble started. Yeah, this shows that we're actually a petroleum-driven society. For the 2018, gross domestic product versus total liquids, which is everything that gas that you put into a gasoline tank. It's gasoline, it's diesel, it's biofuels. So there's a 0.92 correlation. And so what you've got is a very strong correlation, high oil consumption, high GDP, low oil consumption, low GDP. No exceptions. You don't, for example, have, say, high GDP but low oil consumption. So we're a petroleum-driven society. Anyway, that's the sequence.
Wow.
So when it's not a case of this will happen in the future. We're in it.
We're in it. Yeah.
Peak oil could have been a couple of years ago. The blowout in the metal price, which also is related to oil, started in 2005. Things like wealth inequality, that's happening now. Debt saturation, that's happening now. The war in Ukraine, I believe, is a function of this. That's the geopolitical action out of it. It's all about resources. Resources are the new money.
It has been for a long time, hasn't it?
Yeah. So
but you said that things will start to break.
So
what do you mean will break? Is it like another financial crisis, or is it something else?
The financial crisis is actually an outcome of something else.
Okay.
Like that signature I showed you of the 2005 blowout, that put the system under strain, which later created the global financial crisis of 2008. So the GFC was when something broke. It wasn't the cause. And so we're in the situation where the situation's under strain, and increasingly so, then something's going to break. And finance is the weakest thing. So money is at the heart of everything. So when that breaks, all of a sudden everything stops. And we can't do anything. I can't buy books off Amazon anymore, and like that. That's the right. But where we're going with all that, right? Structural things that break are things like food supply. Like the war in Ukraine, for example. Between Ukraine and Russia, they produce the bulk of the world's fertilizer. Yeah. So while they're shooting each other, they're not producing fertilizer anymore. And China, who happens to be their ally, also produces fertilizer. So Ukraine, Russia, and China take fertilizer off the board as a weapon. And now we've got a food shortage. So we've got things like supply of diesel is going to be a problem. Like a lot of the United States is now the supplier of petroleum products for a lot of the world. Like not the only supplier, but they're the swing producer. And a massive chunk of their gasoline that they're producing is the lighter stuff. It's things like petrol. A big chunk of that is coming from the gas industry now, where they're liquefying gas liquids in the refinery. We are forcing an inefficiency in the gas industry to support the oil industry. Now, they can get away for that in the short term. They're not producing bunker fuel for marine shipping or diesel or asphalt for roads, but that's all the heavy stuff. So next year sometime is when it's, unless someone pulls a rabbit out of the hat, somehow. But we could be looking at a diesel shortage, a food shortage, a money. The BRICS economies have made their play, and they've launched the BRICS dollar system, and the Western banking system says, we will destroy you. Right? So what's the outcome of that? One of those actions will destroy the other, and either way, we will see volatility.
Yeah.
So our money systems are vulnerable, our energy systems are vulnerable, our food systems are vulnerable. Almost all of our manufacturers depended on China, who we are trying to go to war with. How do you think that's going to go?
Yeah, so basically the society as we know it, it sounds like.
We've been rolling along like without a care in the world. A lot of our behavior has been quite arrogant. Underneath everything, the original, for example, Club of Rome prediction of 1972 limits to growth report on the standard run. Information's looking like that we're actually on that standard run, which means there comes to a point of great disruption. And to be frank, that's what we're seeing. Right. So the script says everything's going to be, the script says everything is about to be disrupted. What if human innovation was a thing we got out of our own way, we did things differently? And now we don't really have the time, but things are still manageable. But society as we know it has to change. And the longer we refuse to acknowledge that, the more likely that disruption will be ugly.
Yeah. Do you think it's still savable?
I think... So is it savable, question one? Should we save it, question two? Because the current system's over its skis for a reason. Right? So instead of actually just saying, we'll try and sort of patch it up to keep it going, or do we just let it all fall apart and we put our time and energy creating a parallel system and we just transfer to that? I actually prefer that option, even though it's going to be very messy. Try to actually put a Band-Aid on a bullet wound for the existing system, and all its powers and principalities is going to be perhaps more trouble than it's worth.
Yeah.
But in terms of resources, if we did things differently, it could be different. It doesn't have to be like this, guys.
No, but it's gonna be tough to change something so big. It's everywhere. It's in all the documents in companies. It's in all the documents in like government bodies, Agenda 2030 and sustainability. It's so rooted. So I don't see like people going back and starting all over. I hope they do it. But
there's multiple plans on the ground. Some of them are not very nice. But what I'm proposing here is we don't go back to scratch. What we do is we build a parallel system. So we install a series of thorium reactors. Okay, we've got energy, we've got heat and electricity. What do we do with it? Okay, they can be plugged straight into the system. All right, where do we get our transport from? We've got the petroleum systems are starting to become unstable. All right, now we need to develop a new way of doing this. So running many individual passenger cars is more difficult. Let's go to more communal transport. Okay, let's do that. And so not as the entire nation state at once, but we will do it in a small series of steps and stages. And then people can say, this actually works. Let's replicate that system elsewhere.
Yeah.
And so it's going to be that sort of, and you do it in steps. Like the things like the World Economic Forum, the Great Reset. You will own nothing. You will have no privacy, but you'll be happy. And you can sort of hear, put the chip in the brain, you'll feel so much better about eating some bugs. Really?
And be happy, they say.
And
nothing and be happy.
And so they're talking about a radical social change there.
Yeah.
But that change is coming from people who really don't like people.
Yeah, I mean, they're rich already. They enjoy a good life. So,
do they really care about peasants?
Yeah, no one has ever cared about peasants. So
until the peasants get the guillotine out, then they care.
Yeah, then they care. Yeah. But Simon, we never started with an introduction. So to wrap things up, maybe if you could tell people that listens, what do you do and how can they follow your work?
Okay, my name's Simon Michaux. I'm an associate professor of the Geological Survey of Finland. My training is a degree in physics and geology, applied science. And then this is in Australia. I did a bit of training in mining engineering, open pit optimization, geostatistics. I did a PhD in blasting. And then I did research and development in geometallurgy and comminution, the breakage of rock and flotation. And I was in the University of Queensland, Julius Crutchnett Mineral Research Centre for 18 years. I left academia and went into private sector to support feasibility studies in an engineering procurement and construction management company called Ausenco, which I learned a vast amount of the commercial world. While there, I was learning the banking side of things of the corporate world, the banking side of things of how the mining industry operates. I left Australia in 2015, and I left mining to join the University of Liège to learn industrial recycling, and I found the circular economy. I was there for 3 years. I then came to Finland to do mineral intelligence and the circular economy, which is where I am at now.
Okay, so you went from a sunny place to a really cold place.
So what if I told you I'm more comfortable in the cold place than I was in the sunny place?
Yeah.
So Australia, they don't engineer for anything. It says, harden up, you're fine. Whereas in Finland, everything's engineered for the cold. Like, you give me minus 25 degrees outside.
Yeah.
And it's a steady 23 degrees inside at all times.
Yeah.
The Finns have engineered their society very well. And so in Australia, for example, because they don't insulate homes very much at all, not really.
No.
What they call winter, where it gets down to 20 degrees. Oh, the horror, the shock.
Yeah, that's our summer.
To be fair, in some parts of the country, it can get down to 0 at night.
Okay.
Up in the Highlands and stuff like that. But
Yeah.
but that's the floor. Yeah. so,
Yeah.
so
Yeah. Yeah. What a journey you have done. And your work is, I mean, I'm not a professor, but it seems really impressive. It has been really interesting to listen to you and to learn about the current status in the world. And it's nice to see somebody has to have a solution for this problems that we face now. So
yeah.
thank you
So
very much. Yeah, thank you
you're
very
welcome.
much for your research and your time, and thank you for talking to us and educating us. And yeah, it's not a good future that you paint up for us, but let's hope for the best.
We have a future, though.
Yeah,
I am actually ultimately positive for the future once we get out of our own way. We just got to go through some difficulty first because we chose not to look at certain things.
yeah,
Like what
I agree.
motivates me, what gets me out of bed every morning is to do work that actually allows other work to be done that is actually useful. Whereas most of the work thus far in my career has not been that useful.
Yeah. Yeah, I have kind of the same drive. I try to talk to smart people, to professors, and try to spread what you guys teach and what you work with. So more of society gets like alternative views of things and to learn more. And hopefully together we'll accomplish something.
Hmm.
So thank you very much once again for joining us.
You're welcome, mate.
Yeah, thank you. And have a nice time.